How to solve a recurrence relation? If we have this recurrence relation through substitution method, how to solve it? Let's see. Suppose if n is equals to 1, then 1, and if n greater than 1, then t n minus 1 into n. So first we write t n minus 1 into n. Tn is equals to tn minus 1 into n. So how we can write it further? We can write it further t n minus 2 into n minus 1 into n. And further we can break it like this: t n minus 3, n minus 2, n minus 1, or for n we can write n minus 0. So if we go up to 100 times, then what we can get? We can get t n minus 100, n minus 99, like this, up to n minus 0. So like that, if we go up to n minus 1 time, then what we will get? We will get t n minus 1 into n minus 2. Like that, we will get at the end n minus 0. So what we will get from here? N by n will cancel, and what we will get? Plus 1. So t1 into n minus 1, n minus n cancel, plus 2. Like that, we will get 3, 4, n minus 1, n minus 0. So we will get 1, 2, 3, 4, like that, n. So this will be factorial n. So we can say order of small o on n to the power n will be the upper bound, or omega 2 to the power n will be the lower bound. So this by this way we can solve the substitution method. So we can say clearly that what is the order? Small o n to the power n and omega to the power n. In the similar way, if we have this recurrence relation, then what we will get? 1 if n is equals to 1, and t n minus 1 plus log n if n greater than 1. How we are going to solve it? T n is equals to t n minus 1, we write like this initially. How we are going to solve it? Next we can write t n minus 2 log n minus 1 plus log n minus 0. We can write log n minus 0. So further we break, then we can get 3 t n minus 3 plus log n minus 2 plus log n minus 1 plus log n minus 0. So if we repeat it till n minus 1 time, then what we will get? We will get t n minus 1 plus log n minus 2. Like that, we will get at the end log n minus 0. So what we will get? N by cancel will n, and this will be plus 1. So it will get t1, and n cancel by n, then what we will get? Log 2 plus log 3. Like that, at the end we will get log n. So further we are going to solve it, then what will we get? 1 plus log 2, 3, and so on up to n. Further we are going to solve it, then how we can write? We can write like this: 1, 2, 3 up to n. So what we will get? This is factorial n. We all know this is factorial n. So how we can write it? 1 plus log n to the power n. Factorial n is equals to n to the power n. So what it can be? 1 plus n log n. So initially what it can be? It can be order of n log n. So in this way we can solve a recurrence relation by substituting the value. With the substitution method, we can find out what is the complexity and what will be the order of that recurrence relation.